Dear students, welcome to our online classes. I am Ravi Kumar KR, lecturer in Computer Science, gsipucmysuru College, MYSURU. Students, in my previous session, I have explained you about algorithm, features of algorithm, importance of algorithm, and analysis of algorithms, time-space trade-off, stepwise refinement, and we have practiced few algorithms. Now, in this session, let us start with one more concept, that is flowchart. You know what is a flowchart? Flowchart is a diagrammatic representation of solution to a problem. So this definition I have explained to you in my previous session. So in previous session we have worked out algorithm. So what is algorithm? Algorithm is a textual representation, whereas flowchart is a diagrammatic representation. We'll use some geometrical shapes to draw flowcharts. Now let us see what are the importance of algorithm. What are the importance of algorithm? The first point is communication. It is the best way of communication of logic of a program. This is a diagrammatic representation. So this convey in a better way the logic of the program. Means easy for us to understand the logic of the program, because flowchart is a symbolic representation or diagrammatic representation. Second point is effective analysis. Students, you know what is problem analysis. That is, in problem analysis, you have learned that how to analyze the problem by looking at the input, type of data, and what is the output, and some additional information. See, that is we had discussed in my previous session. So similarly, with the help of flowchart, problem can be analyzed easily. Any flowchart or problem can be analyzed easily with flowchart. Next point is effective coding. You know what is coding? Coding is nothing but conversion of algorithm or flowchart into program, or in other way, writing a program in any of the high level language by looking at algorithm or flowchart. So here it is easy for program development means that by looking at the flowchart, it is easy for any programmer or the user to write or to convert flowchart into program. So this is effective coding. Fourth one is proper debugging. What is debugging? You know that is finding out the mistakes and correcting those mistakes in a program is debugging. So debugging is easier. Or the process of debugging is easier for the programmer. Fifth one is proper documentation. proper documentation. You know what is documentation? A reference material for the benefits of the user, and in documentation we are going to mention, or they are going to mention, how to use particular product or software. Flowchart, it acts as a guide or a user manual for documentation. So flowchart, it acts as a better documentation for any particular application or program. 6 point is maintenance. You know what is a maintenance or program maintenance? The program maintenance is nothing but to update the particular software or application based on the user requirements. That's the definition we have learned in our previous sessions. Flowchart helps us to maintain a particular program or applications easily, or it is easy for programmer for maintaining particular application or software. Students, these are all the points or importance of flowchart. It is a diagrammatic representation of certain problem. What is importance of flowchart? Communication. So because it is a symbolic or diagrammatic representation, easy for the programmer to understand the logic of a particular program or an application. Effective analysis. So problem can be analyzed easily. Coding means converting flowchart into program, that is coding. It is easier, or it will help the programmer in proper program development. Proper debugging means debugging is easier. What is debugging? Correcting and finding the mistakes and correcting those mistakes in a program is debugging. That is much more easier. And proper documentation, this flowchart acts as a guide or a manual for proper documentation. 6th point is maintenance. So with the help of flowchart, easy for us or a programmer or the user to maintain the particular application or software. Now let us learn the symbols used in writing flowchart. Symbols used in writing flowchart. First one is oval. This indicates start or end of a flowchart. Second one is parallelogram. Input and output. Next one is rectangle. This is for processing or calculations. Fourth one, rhombus. This is for decision making. This one is used for decision making. Fifth one is preparation. This is for loop. Predefined process. This is for subprograms. Circle. This is used for connecting different flowcharts, or it acts as a connector. Next one is flow lines. Arrows. Let us see the different geometrical shapes used in writing a flowchart. Here, this is first one is oval. This is a oval shape. It used to indicate starting and end of a flowchart, because every algorithm or flowchart has to start and it has to be closed at particular stage. We are using this oval shape to start and end a flowchart. Parallelogram. This is the geometrical shape used for input-output operation, because you know that every flowchart must accept the values and every flowchart must produce a meaningful result. To represent those statements, we are using this parallelogram. And rectangle. This is a rectangle for processing or calculation, means where we have to write the formulas or computation steps we are writing within this box, that is for processing or calculations. And this is a rhombus. Rhombus is used in a program for decision making, where we may have to take decision. Those decision statements we are writing are conditioned within this rhombus. And next one is a preparation. This is a symbol. This is nothing but for loop. This is for repetition of statements in a program or in algorithm or flowchart. And predefined process, nothing but subprogram. Next one is circle. This circle is act as a connector, or it's going to connect different flowcharts written on two different places, on two different pages. Next one is flow lines. These are arrows. These flow lines used to connect different steps or the flow of logic within a flowchart. So these are all different geometrical shapes used while writing or drawing flowcharts. Now let us practice few examples to find area and circumference of a circle. First, you know, area of a circle is pi r squared. Circumference is 2 pi r. Already we have written algorithm for this. Now let us write a flowchart for the same. Now each flowchart must start with oval shape. This is the beginning of a flowchart. All statements what you are going to write with, it should be within this geometrical shape. So please practice the same. Next, this is start. Step 1 is, you know what is step 1 here? This is we have to accept the values of radius. So there is input, radius. We are using a parallelogram. It accepts the values or input values. So here in this example, we have to input only radius or radius. So next step is applying formula. Next step is applying formula. A is equals to pi 3.14 into r into r. This is one formula. And second formula is circumference. I can write C equals 2 multiplied by pi 3.14 into r radius. So this is processing. Input, process. Next step is output. Again we are making use of this parallelogram. parallelogram, this is output. So we can write output, area and circumference. A stands for area, C stands for circumference. After printing the result, we have to close this flow chart with oval shape. And here we say stop. These are the steps, and here this is, we know the step 1, step 2, step 3, but how do we connect all these things? We are using flow lines to connect different steps. See, this flow lines with arrow is very important. It indicates flow of logic. So by looking at this, we can make out this starting point. Next is this step, next step is this, and next step is this, and finally we have to stop here. So by looking at the flow lines, we can easily make out flow of logic in a program or in flow chart. So here start is indicates beginning of a flow chart. Input, this is have to accept the values of radius. So here we have to input, or we have to read the value of R. Next one, applying formula, this is processing. See, this is input and output. We are using same geometrical shape, parallelogram, accepting the values and printing the values. And similarly, this rectangle is used for processing, or where we have to write the formulae or some calculation steps we have to write in this box, the rectangle for processing. Next, we have to stop it. So oval, this is oval is used to start and end an algorithm. Parallelogram is used for input as well as output statements. We are using rectangle for processing or computational statements. So this is an algorithm to find area and circumference of a circle. Next example is again to find area and circumference of a circle where the sides are given. The formula is area equals square root of s into s minus s1 multiplied by s minus s2 multiplied by s minus s3. Here, what is s here? S is nothing but to add s1 plus s2 plus s3. So in order to find out an area of a circle, we should know the values of s1, s2, s3. Then according to the formula, we have to calculate area. So step 1 is, first we will start an algorithm. Next step is we have to accept the values of s1, s2, s3. That is input or read s1, s2, s3. It should be inside this geometrical shape. After reading this, we have to find out what is s. S is equals s1 plus s2 plus s3. This is, it should be inside rectangle because it is a processing. Next, we have to find out area. Again, it is a processing. So we write like this: A is equals to, we are using one function sqrt. Inside this, we are writing this formula. That is s multiplied by s minus s1. This multiplied by s minus s2 multiplied by s minus s3. So we have to close this bracket. So this is a processing. It should be within a rectangle. So this is processing. Next step is we have to print area. We are using parallelogram to print the values or print the result. I can write here print area, print area, and finally we have to stop this flow chart, stop, and we are connecting different steps through these flow lines. Okay, students, this is a flow chart to find area of a circle where values of S1, S2 and S3 are given. Starting algorithm with oval, ending with oval shape, input and output within this parallelogram, and processing is within this rectangle. This is a flow chart to find area of a circle. Next example is to interchange the values of two variables. To interchange the values of two variables. Let A and B are two variables. Assume that we have given the values as 10 and 20. So this flowchart or program should be interchanging of these two variables, or nothing but to swap the values of two variables. Output should be A value should be 20 and B value must be 10. So this is the program, or we have tried a flowchart for this. Any program will be having more than one approach or one method. Now let me explain one of the logic by using one more variable temp. One more variable temp. What is the logic of this program now? Let A and B are the variables. Temp is one more additional variable. Suppose 10 is the value of A, 20 is the value of B. We push this 10 to this place here. So this will be 10. Once we push the values of A to temp here, this 10 will be as it is. It will not be erased or cleared. So after moving this, we have to bring this 20 to this stage. Value of B into A, then it is going to overwrite on the existing value of A, that is 10. So A value becomes 20. So now A value becomes 20, this also 20, and here we have value 10. So we push here. So it is going to overwrite on this, it becomes 10. So at the end of this process, value of A becomes 20, value of B will be 10. So these values have interchanged, or we have swapped the values with the help of this logic by using one more temporary variable. Now let us write flowchart for the same. First step is start. Second step is we have to accept two values, or we have to read two values A and B. So I can write read A and B. After this, next step is only processing. So we have to write the steps. Here, as I told you, first step is to bring value of A into temp here. So I write here temp equals A. The meaning of the statement is value of A becomes temp. This is the statement. Next, we want to push value of B into A. A equals, we write A equals to B. The meaning is that value of B will be value of A, or in other words, we are pushing the value of B into variable A. After this, we have to push these values to a variable B. Next, we say B equals temp, means the value stored in the variable temp. So these are the three steps using to interchange the values of two variables. This is processing, it should be within rectangle. Next one is, after this, we have to print the result, means we have to print the values of A and B. That is, I can say print A and B. Finally, we have to stop, or we have to close this flow chart. Then connect these different steps through flow lines. So students, this is a flow chart to integer the values of given two variables. Here, what is the output of this? See, at the beginning, input will be A equals to 10 and B equals to 20. At this stage, while printing, it prints our output will be as A equal to 20 and B equals to 10. So, this is the flowchart to integer the values of two variables by using third variable temp. Next example is to find greatest of two numbers. To find greatest of given two numbers. Students, here this flowchart will be slightly different from previous flowcharts because the logic is different here. And here, if we want, for example, two numbers A and B are given here. Now we have to print which is the greatest. Accept the values. For example, 5 and 6. Logic is we have to compare one with another. For example, like A greater than B. When you compare two variables here, possibly there are two answers, that is, one is yes and one is no. There are two possible answers, either yes or no. Suppose if I say this is 6 and this is 5. If you compare this, A is greater than B, it is true or it is yes. So we have to take this statement. Now, see, this is 2 and this is 7. In this example, if you compare two numbers, A greater than B, here A value is 2, B value is 7, is A greater than B? So answer is no. Then we have to process or we have to continue with this statement. So this is the logic here. So in this flowchart, we are making use of rhombus. You know what is rhombus symbol? This is rhombus symbol is used for decision making statement. So we have to make use of those rhombus symbol to compare two values. Accordingly, we have to proceed with the solution. Now let us write a flowchart for the same. Start input numbers input A, B. Next step is to compare two numbers with the help of rhombus. So here this is rhombus. Here we have to write the statement A greater than B. Any decision making statements or this rhombus will be having two outputs, that is, one is for yes and one is for no, or one's for true, one for false. It can be anything here, but in this, if A is greater than B, then it will be true. Suppose if A is less than B, this will be the statement to follow. So the rhombus box will be having one input. We can write like this. This is flow lines. It takes one input and produce or gives two output or two branches. We have to consider both the statements and we cannot ignore any of this. Suppose if it is true, we cannot ignore this, and suppose this is true, we should not ignore this statement here or this branching here. So that is why this rhombus decision making box, it takes one input and produce or gives two outputs. So in this example, A is greater than B. There are two possible answers, yes or no. If it is yes, we know that A is greater. So we have to print the answer as A is greater, and if it is, see, we are connecting like this, If it is no, it is understood that B is greater, that we have to write inside this. So here we can write B is greater. So once if it is A is greater here, if A is greater, we have to print A is greater, then we have to stop this flow chart. So we are using here oval to stop the flow chart, and note that we are connecting this flow lines into this and this one to this. Now students, understand this logic here. If A is greater than B, there are two possible conditions, yes or no. If it is yes, it has to print A is greater, and here too it has to stop at this stage. Suppose A is greater than B, no means B is greater, it will print B as a greater number, then you have to stop at this stage. Suppose if A is greater than B, it prints A is greater and stop it, and it will ignore this statement. If B is greater, in that case it goes to this branching, it prints B is greater and stop this flow chart, and it will not consider this part or this statement. So this is an flow chart to find greatest of two numbers. Students, let us continue the remaining examples in my next session. Thank you very much.